Hello, everyone. My name is Mohamed El Dessouki. I am CEO at ViaBlock Limited. We are a UK-based company incorporated in 2018, and we are mainly focusing on emerging technologies, specifically blockchain and its implementation in data networks and telecom industry in specific. I come from a long background of telecom operator experience, and I am specialized mainly in the operations of IT systems and data networks. With me today is our CTO, Moustafa Ali. He is a guru in data networks and routing technologies, and he has been focusing on emerging technologies and blockchain implementations for the past 7 years. We are privileged to present in front of you today, and it is our pleasure to be presenting in front of the British Computer Society, the Internet Specialist Group. And we would like to talk to you about JACS. JACS is our totally new communication stack. We are aiming to change the way data networks currently work by leveraging blockchain over a totally different communication stack to be able to provide a decentralized infrastructure for the Internet 3.0. JACS is revolutionizing Internet 3.0 infrastructure. And for you who would not know Internet 3.0, it is the Internet that is based on decentralized services and applications. Before I go into much detail, I would like to let you know that our presentation is going to be almost 1 hour long, maybe a few minutes more. And we will allow at least 20 minutes for Q&A at the end. So please, as your questions arise, write them down in the chat window and we will address them as they come in during the 20-minute Q&A session at the end. And if we have more time, we can take more questions at the end. The session is going to be recorded, and we will distribute the recording afterwards, and we will also distribute the material for your reference. The presentation is going to be around almost 60% technical. So for those of you who are technical experts, we are looking forward to discussing with you and learning, of course, from your comments and feedback. For others who might be a little bit less technical, we hope that we will be able to communicate the idea as well as introduce new concepts to you. Going back to JACS, we are aiming to revolutionize Internet 3.0 infrastructure by providing a platform that addresses 4 main issues that we see with the current Internet infrastructure. Firstly is the address abundance, providing enough real addresses for things and nodes that are aiming to get real addresses for their internet connectivity. We shall also focus on the security, internet security, and we would like to avoid, or we are aiming to avoid, the high recurring fees completely altogether, and also the initial high fees that are currently paid to acquire address blocks. Lastly, it is a fully decentralized platform that would enable the decentralized applications and services to focus on their deliverables and plug in over JACS so as to handle their data transport in a decentralized manner. JACS, we consider it as a main contributor to Internet 3.0. We are putting it forward as an infrastructure of choice for services and applications to be developed, and for the ones which already exist. To name but a few, IPFS, which is presenting a decentralized hypermedia protocol, Namecoin for decentralized DNS services, Filecoin for decentralized storage, Golem for decentralized computational power, Storj for cloud storage, Steemit as a decentralized social media platform. We are aiming to put JACS forward for these applications and the ones that will be coming in the future, so that they can use the platform directly without having to worry about their decentralized transport mechanism. I'll start, of course, by the people who are behind this project. I would like to start maybe by myself. I come from 20 years experience in multinational suppliers and service providers. I am an expert in network and IT operations, and I have been in consulting and system integration for the past few years of my technical career before starting off via Block. With us, as I had mentioned, Moustafa. Moustafa is our CTO, and he is the expert mind behind the IP routing and data communication, as well as the implementations of blockchain within the industry of telecoms. Our team is supported by advisors who are experts in their domain, and we are privileged to have one of them even with us today in the audience, Mr. Jordi Pailesi. And he is a PhD candidate in computer architecture in the Technical University of Catalonia. He is the one who is supporting us with the internet architecture and the implementation of blockchain in the infrastructure protocols. Another expert in his domain is Mr. Lucas Lukowski. I don't think he's with us today. However, he is our reference in the open networking domain. He is an open networking foundation and an open commute project ambassador. And our team is quite diversified at this moment. We would like to introduce also Mr. Anton Bondarenko, who is our prototype lead engineer, who supported us with the prototype creation, development, and our Linux kernel developer, Shreya. I am mentioning those because I would like to highlight the diversification of our team and the fact that we are decentralized in nature so far, since we are in like 6 different countries. Our team also includes our brand specialists and legal advisors. Having given this introduction, I would like to let Moustafa come in and start off with introducing the problems initially that we have decided to handle within JACS. But before that, I would like to welcome all our guests who joined a little bit earlier. I hope that my introduction, you managed to capture at least part of the introduction. If not, then at the end, if there are any questions, we can take later. Please, Moustafa, take us through the problems.
Sure. Thank you so much, Mohammed, for the introduction and for introducing me. So, hello, everyone. My name is Moustafa Ali. I am the CTO at Via Block Limited. And as Mohammed mentioned, I have around 19 years of experience, mainly in the data networking field, working with regional, local, and multinational service provider and mobile operators all over the world. And like 5 or 6 years ago, I started focusing on all kinds of emerging technologies, including open networking, SDN, and definitely above all blockchain. Under my belt, I have a couple of highly recognized industry certifications. I'm an active CCIE certified, Cisco certified Internetwork expert from Cisco since 15 years ago, and an OCSA, Open Networking Foundation certified SDN associate since like 3 years ago. Okay, so back to our topic, JACS, and the problems that we've seen and we've witnessed that the internet community was facing since quite a long time. We've included here 4 main issues. To start with, is the IPv4 address depletion. That was anticipated since late 80s, last century, because of the relatively limited number of IPv4 addresses. Theoretically, we have around 4.3 billion addresses, while in reality, not all addresses could be used. So because we have the subnet addresses, we have the broadcast address, we have certain specific usage addresses, multicast addresses. So the number of global used addresses is less than 4 billion addresses. And with all the unfair initial allocation of IPv4 addresses since the start of the internet, as well as the exponential growth for the internet demand, the depletion was anticipated long ago. It started to happen. I mean, the last IPv4 address was formally or officially allocated back in Q1, the first quarter of 2011. Since that time, service provider and mobile operator all over the world are struggling to acquire used IPv4 addresses from the after sale market in order to cope with their exponential demand for internet services. The second problem is the high recurring fee. So service provider and mobile operators don't only need to pay a huge upfront fee to acquire any IPv4 or even IPv6 address block, but also they need to pay an annual high maintenance and renewal fee. Third problem is it's one global well-known issue for the internet security, that what we call and what is known for the BGP hijacking, when some rogue person tries to fool the internet community is that they own certain addresses belonging to someone else, maybe to Google, and then start to advertise those addresses, causing all kind of denial of services for the original address owners. That is happening a lot. If you type BGP hijacking in Google and over Wikipedia, you can find frequent incidents on what is going on in that regard. Last but not least, the IPv4 and IPv6 addresses allocation are centrally controlled and governed by IANA, which is the central authority for the internet and autonomous system number over the internet, below which came 5 different regional internet registries, or what we call RIR, that we will cover the coverage in a few moments. Next, please, Mohammed. Okay, so let's start by mentioning some of the solution attempts for each and every problem that we have mentioned so far. So for the address depletion, the very well-known solution was and still is NAT, Network Address Translation. NAT is a mechanism that allows your an enterprise users or a service provider clients to utilize private addresses, and then it's the role for the service provider or operator to take care of translating those private addresses into one or few or multiple public addresses before allowing the client to browse the internet. NAT comes with different versions and variants like NAT64, like carrier grade NAT, like PAT, which is the port address translation. It's not our scope now to cover each and every single aspect of NAT, but NAT is a solution. It has lots of drawbacks, as many of you may know, with some applications using NAT, not working through the firewalls or over the internet, and all that kind of known issues. Then, a couple of decades ago, the IETF decided to come up with a new replacement for IPv4, which was the IPv6. That was a brilliant solution, because instead of depending on 32 bits addresses for the IPv4, giving the 4.3 billion addresses, the IPv6 header was able, or is still able, to accommodate 128 bits, giving us a huge order of magnitude compared to the IPv4. But in reality, the rate of adoption from the internet community to IPv6 didn't go as it was planned for, or as it was expected. And the below graph shows the slow adoption of IPv6. That was perceived as a long-term solution for the IPv4 depletion, but in reality, it didn't succeed to achieve this high goal. Then, starting from TUBA stands for TCP and UDP over bigger addresses. TUBA was a solution attempt, or it was an initiative that thought out of the box. I mean, that tried to find a replacement to the IP protocol altogether, and that didn't depend on IPv4 or IPv6. They thought of combining the TCP and UDP, normal TCP and UDP ports, with some communication stack. And by the way, that will be the core of JACS, and we will talk about it in great details shortly. Its name is CLNP, or CLNS, Connectionless Network Services. But again, TUBA didn't go anywhere because of the need to migrate the full internet from TCP IP to CLNS at some point, because of all kind of centralized services like DNS that failed to cope with that proposed solution at that time. Then came the ATN, again with CLNP. ATN stands for Aeronautical Transport Network, and that is the one taking care of the aerospace industry, because it is a huge industry. It always requires lots of addresses. That's why they thought of CLNP as a replacement to IP, but again, that initiative didn't achieve its goal and stopped all of a sudden 12 years ago. I remember it was like around 2008. Talking about the internet security, and I'm so sorry guys if I am muting some of you because we only need to have the voice clear for all the other audience. Again, if you have any kind of questions, please don't hesitate to write those down in the chat window, and directly after the presentation, we will be having a 20 or 30 minutes Q&A during which we will cover every question you may have. The internet security, we're talking about the BGP hijacking, you know. So in order to verify and authenticate someone as the real owner for certain IPv4 address block, the RPKI, or Resource Public Key Infrastructure, was created. And it was meant to be a central repository where the legitimate owner of IP addresses, autonomous system numbers, need to tie some kind of security certificate, tying their identity in a central location where all internet routers can verify the authenticity of certain advertised routes versus the RPKI database. This way, if some internet router is accepting some advertised routes, it only needs to check the authenticity of those routes against the RPKI database in order to verify that those addresses really came from the real owner or from a rogue person or some attacker or some hacker here and there. Happened between the IPv4 address owners and the security certificates. Like 10% of the address owners were only recorded over the RPKI, but that was anticipated to record each and every IPv4 and IPv6 address owner. Hence came a brilliant solution named IP Chain, and that was created by Mr. Jordi, our advisor, among others. That was a brilliant blockchain idea on how to store IP addresses, allocation, and delegation over the with some mechanism over blockchain, thus solving the conflict between the user ownership and the centralized security certificate by having the blockchain taking care of that. Blockchain, by its nature, as will be highlighted shortly, is distributed by nature. It is not run by certain authority. It is run by the community or by consensus. That's why getting blockchain into the mix of such a solution to solve the verification and validation of the internet addresses was an amazing idea. Next, Mohammed. Okay, so we were talking about IANA and the 5 different RIRs falling under IANA, and how they not only require the service provider and operators to pay a huge upfront fee in order to acquire an IPv4 or an IPv6 address block, but again, those owners need to pay an annual high fee. So taking, for example, from the graph, a /24 subnet, we can find that the annual renewal cost per year is around $75,000 for an IPv4, a /24 or a Class C subnet in South America. That is huge. That is a ridiculous number. Next moment. This map highlights the coverage of the 5 different RIR. So in Africa, the RIR is called Afrinic. RIPE is taking care of Europe, some part of Asia, as well as some part of the Middle East. In North America, it's AREN. In Central and South America, it's LACNIC, and APNIC is taking care of Asia Pacific and Australia. Okay, so let's talk about JACS as a solution. To give you a nutshell, to give you an introduction about JACS in a nutshell, it is the mix, and it's all about combining 2 components. One is blockchain, and the other is the communication stack that we talked before during the presentation of the previous attempts with the name of CLNS. CLNS as a protocol has 160 bits of addresses. So if you can see the graph, the order of magnitude is insane because we are talking about binary number. So each bit added to the address makes a double of the available addresses. So you can see the order of magnitude for JACS addresses. It's a huge number. In order to facilitate reading the figure, it's 1.4 followed by 48 zeros, and it's quite a lot. In JACS, there is no central authority to request blocks, addresses blocks for, or to give any justification for the need. The addresses are abundant because of the 160 bits, as we said, and it's very good and very suitable solution for IoT, for addresses hungry application like the global 5G rollout and the Internet of Things. The address advertisement all happen over the blockchain, so avoiding any kind of security flow or BGP hijacking. There will be a minimal cost to acquire any JACS address block, and there will be zero maintenance fee. So we don't have any maintenance fee, we don't have any renewal fee. So you pay an upfront fee, it's a minimal cost with JACS tokens that we are going to talk about shortly, and your addresses will be with you forever. Last but not least, regarding the solution, a year and a half down the road, starting for the initial development, we are going to have a bundled solution. So JACS will not only be a software-only solution, instead it will be a bundled solution by combining JACS software over some specific hardware that we will talk about. Next, please. Comparing CLNS to the TCP/IP, because we are saying that we are replacing the TCP/IP. So for the ISO OSI 7 layers model for data communications, we need only to highlight the difference in layer 3 and layer 4. So in layer 3, that is called the network layer. So instead of having the IP in the TCP/IP stack, it's either IPv4 or IPv6, we have the CLNP, connectionless network protocol. In the transport layer, instead of having TCP and UDP, we have the TP4 for connection-oriented transport protocol and CLTP for connectionless transport protocol. Next, please, Mohamed. Okay, we talked about NSAP addresses. Those are the 160 bits long. But let's give a brief history about the origin of the NSAP. The NSAP addresses was first defined in ISO 8348. And now, as we speak these days, every router from a well-known vendor like Cisco, like Juniper, like Huawei, like Alcatel, is using the NSAP address to configure a specific routing protocol named ISIS. ISIS routing protocol is using the NSAP addresses, but not for data transport as we are doing with JACS, only for the communication between the different routing nodes. Briefly, it is divided into 3 main parts, one of which is the area address, and then the system ID, and then the cell or selector. The NSAP selector is somehow equivalent to the TCP port number and UDP port number. Next, Mohamed. More than a couple of decades ago, there used to be lots of initiatives to reformat the NSAP address according to the different countries or government. One of the most notable one was GOSIP version 2. GOSIP stands for Government Open System Interconnection Profile, where the different government, like the US government, was trying to format the NSAP address in a very specific way to match their requirement. So the NSAP, as we said, is composed of different components and different subcomponents. The US government was fixing the decimal notation of 47 for the subcomponent name AFI, or stands for Authority and Format Identifier, and decimal 5 for the IDI. So any NSAP address at the time starting with 47.000 or 0005, you can always ensure that it is coming from the US government and it is coming from the US. The different fields were left for the different authorities and different operators to play with and manipulate on their own in order to allow the different routing domains, different areas, and different system IDs as well. Next, please. JACS is using NSAP addresses because it's using the CLNS protocol, but we are starting from a clean slate in terms of NSAP addressing. We are not following any one format or recommendation for NSAP addresses before. We are preserving some component and subcomponent that were created by the GOSIP v2, but we are defining all components on our own. And unlike all previous specification, we are always defining the 20 bytes or 20 octets of the 160 bits NSAP address in hexadecimal presentation. We are not going to have decimal and hexadecimal mix. Oh no, it's only hexadecimal. And by hexadecimal, I mean we are going to use the number from 0 to 9, as well as the letters from A to F. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10, it's decimal. But in hexadecimal, it's A, and then B, C, D, E, and F. Next, Mohammed, if you please. So we have different description for the different components. I will pass quickly through this slide because it has lots of details, technical details, and as Mohammed explained, the slides will be shared with you so that you can look into it quite well, and you can always check our white paper to better understand what we meant by each and every component from the NSAP addresses. But let's say for the AFI field, authority and format identifier, if we have the address starting with FF, that means JACS over its own blockchain, not over Ethereum. And we will explain the difference in a coming slide. If we have the IDI, initial domain identifier, all zeros, that means that we don't have any kind of geolocation. You cannot identify that this address is coming from the UK, this address is coming from Germany. You cannot do that. Geolocation is disabled. But if we have the IDI following the specific country calling code, you can tell. So if you find the IDI 0044, you can say that this address belongs to someone. It's anonymous person, some service provider, some individual, some operator, mobile operator coming from the UK. And we have different fields in the DSP or domain specific part as well. So let's pass through those quickly. Next, Mohammed, if you don't mind. Blockchain. Blockchain is the second vital component of JACS. And if we are required to explain blockchain and to talk about blockchain, we definitely don't need an hour. We maybe would need a week or a month or a year because of all the good things happening, starting from the invention of Bitcoin 11 years ago. Because when Bitcoin was invented by Satoshi, he or she or they, we don't know, created blockchain in the initial Bitcoin white paper. So Bitcoin is the application running on top of the underlying technology named blockchain. Since then, blockchain was not only used as for monetary purposes, but it's used for anything, supply chain, real estate, and now we are talking about blockchain for telecommunication, as you can see. Blockchain or DLT or distributed ledger technology, it's all about having the different dispersed distributed nodes having the same exact copy of the database or of the ledger in order to use the right terminology of blockchain. Next comment. What are the general functions of blockchain? So what are blockchain used for? First function, obviously, is the creation and distribution of digital assets like coin, like Bitcoin, like token, any token. You've definitely heard about lots of Ethereum, Ether, like EOS, like Namecoin, like Filecoin, the one that Mohammed mentioned during the Internet 3.0 slides. But starting from blockchain 2.0 that was created around 2014, if I'm not mistaken, they have created a brilliant idea of a smart contract. So you can have a contract running on its own over blockchain. So you only need to configure some code, you only need to configure some balance, you only need to define a criteria, and the code, once it's executed, no one can alter or change its status until full fulfillment, until it finishes its intended process or objective. That is brilliant. Think about anything you can do. Think about someone paying someone a money after they finish some specific task. So it's all being coded and recorded over blockchain without any intermediaries and without any third party to audit or to verify or any kind of escrow service as we are using in real money or banks in the middle in case of money. Mohamed? JACS and blockchain. JACS, blockchain is a vital component for JACS. It's actually the second component of JACS beside the CLNS. What is blockchain doing in JACS? Doing many functions like the address allocation, address registration, verification of addresses so that the internet is very secure once it runs purely over JACS. That's our ultimate goal, obviously. Preventing any kind of BGP hijacking. We are using blockchain for our crowdfunding, private and public crowdfunding, as will be detailed later. And we are using blockchain and our JACS tokens to reward the current IPv4 block owner. Why? To encourage people to move away from TCP/IP to JACS. So we are giving them some incentive, as we can say. And also to incentivize the community and to incentivize the early adopters of JACS. We are encouraging people to try JACS and be our fans, you know, and to play with JACS, deploy JACS. JACS will start over Ethereum, and it is, if we can say that Bitcoin is the king of the cryptocurrency, we can always claim or say that Ethereum is the queen of the cryptocurrency. So we are gonna use Ethereum public blockchain for JACS operation starting from its first release, what we call the pre-alpha, till the official release version 2, and that will be shown in the roadmap as Mohamed will go through in a moment. And we are gonna use Ethereum as a way to raise fund, crowdfund as well. Mohamed? Okay, talking about Ethereum and dAPP. What is a dAPP? A dAPP is a distributed app. It's like a normal app. It's like a conventional app, but it is built over blockchain. So hence the name distributed app. Over the Ethereum blockchain, dAPP are built using smart contracts. And smart contract, as we said, is they only need some code, some transaction, some balance. And because a dAPP exists, and it's like a normal app, it needs storage. The issue with Ethereum is that everything you need to do with the Ethereum blockchain, you need to pay some gas, what they call gas for it, in Ether. And Ether is the coin over the Ethereum blockchain. Why you need to pay some gas or some cost for each and every transaction? Because you need to pay for miners, and those are people or nodes producing blocks in order to always maintain the good shape of the Ethereum blockchain. Theoretically speaking, we can have infinite storage over the Ethereum blockchain, but practically, we need to pay a lot of money to store information over the Ethereum blockchain. So it's very costly in general to store 1 byte of data over the Ethereum blockchain. And that will represent a main issue on how JACS will operate over Ethereum, but we will explain in a moment how we are overcoming and working around that. Mohamed? A question or an argument may arise. Why you are using an existing blockchain? Why you are not creating your own blockchain from the start? That's a very good question. Later on, down the road, we are gonna create JACS native blockchain indeed. But for now, we need to focus on the implementation. We need to focus on the deployment and development. And we need to focus on fine-tuning the different JACS versions before reaching the step or phase where we can see that we are ready and now it's time to develop our own blockchain. And because Ethereum is offering lots of smart contracts and dApps creation tool, and the number of software developers who are now very well skilled in the Ethereum development, is getting higher and higher every day. You can find lots of good Ethereum, brilliant Ethereum developers over freelancers platform like Upwork or Fiverr. You know, you can get someone to code to you whatever you want over Ethereum. But again, we do have the issue that we talked about in the last slide. How could we store the different and abundant address from JACS over Ethereum? It will be very costly. So we find a solution. We are going to integrate Ethereum with IPFS that Mohamed talked about during the first slide. IPFS is some kind of distributed file storage system and file sharing system where you can store your file in different locations distributed all over the world and not in a central location. And you only need to have the key to get and gather the different pieces of file and unlock it, you know? So we are gonna keep the key, or what we call the hash, over the Ethereum blockchain, and it's gonna consume much memory and much storage over Ethereum. So we are gonna keep the hash on chain, while the actual mapping of addresses and the actual addresses are gonna be stored off chain or over the IPFS. Next comment. It's yours.
Right, I would like to maybe take you a step backward a little bit from the amount of technical details Moustafa has been taking us through, and give you the JACS story in simple terms. And of course, I would like to go through the roadmap so as to collectively gather all the aspects and features that Moustafa has been talking to us about in the previous few slides. JACS didn't start with via block in 2018. It even started earlier. And here I'm saying that the beginning was there in 2017. Actually, not really. I personally started looking into the implementation of another alternative to IPv4, and at that time, in around 2005 timeframe, I was doing my master's thesis, and I studied the implementation of IPv6 on the mobile data communication applications. Moustafa also had developed a few trials on the transport of data traffic over blockchain-based solutions across the public internet. In 2018, we started our collaboration, knowing that we have identified a few problems and wanted to go about fixing them. And this is where the idea came with JACS. So we gathered the team and we incorporated via block in November 2018. We identified the new communication stack features that we would like to implement. And we went directly into the creation of our prototype. We started off with the analysis of the protocols, and we checked the previous efforts done in the ATN network and identified CLNS as our protocol of choice. We started immediately to revamp the old code of the CLNS. It's an old, already existing for a few decades network protocol, and we developed our prototype. So we do have the minimum viable product published on GitHub, as it is an open source product for now. And we funded this from angel funding, as well as, of course, our own personal investments. Throughout the past few months, we have been working on private sale so as to be able to fund the next steps and be able to pay for the PR and related listing and marketing activities, as well as making sure that we have enough juice for the creation of the different versions of JACS. So starting from next month, we will go through our public crowdfund, followed by the development of our pre-alpha version. So we are going to take JACS from a pre-alpha version based only on Linux distributions over to the alpha version where we support more operating systems, next to the beta version where we do a major shift from the intra-domain connectivity to the inter-domain connectivity. So we will introduce the concept of early adopters as enablers, where we will use our JACS dual stack running node users as enablers to tunnel the data across the IP internet so as to move JACS traffic from one dispersed island to the other. Followed by our official release version 1, where we anticipate a growth in the traffic profile. We will then move the tunneling across the public internet to the JACS public cloud instead of relying on our users. Then from official release version 2, JACS is going to move from Ethereum up to its native public blockchain, reaching official version release 3, which is the final packaged product, where we are going to be delivering JACS as a fully bundled solution over hardware. This will allow entities and enterprises to perform their network modernization and their networking equipment migration as planned. Quickly going through the evolution and milestones, as I had gone quickly through them in the roadmap. Currently, we have our MVP. It is a fully functional product that is showing the capability to transport data over non-TCP/IP protocol. The pre-alpha, alpha, beta versions are going to be software-based, as well as official release 1 and official release 2, all of which are going to be software-only versions of the product, with the different features building up as I had explained. So we start off with Linux, then we support more operating system. We use our adopters as enablers for inter-domain communication. Then we replace them by the public cloud for a bigger traffic profile. Then we move out of Ethereum into the JACS dedicated blockchain, reaching official version 3, which is the final product that we are going to be offering to and catering for the different market segments, starting from small office, home office type of business that would require a small block of addresses, going through small enterprises, medium, large, X-large, and even catering for service providers and carrier grade requirements of address blocks. This version is going to be integrated over white boxes, and I'll explain for those who might not know what white boxes are in the next slide. Quickly going through the versions and the main highlights of the different versions of JACS. So in the MVP, we are not using blockchain. We are just proving the concept that we are able to transport data over CLNS, and pre-alpha, alpha, beta, and official release 1 are all based on Ethereum blockchain. The authority and format identifier AFI in those early versions are going to be updated from FA, B, C, D, and E to show that we are working on a non-JACS native blockchain, with the initial domain identifier all set to 0, meaning that there is no geo-enablement. You cannot identify from the JACS address header whether this address is located in a certain country or not. But as soon as we move towards our native blockchain, we will introduce the geo-enablement feature, and the authority and format identifier AFI is going to be fixed at FF, showing that this is the version running over the JACS native blockchain, and the IDI, the initial domain identifier, is going to be represented in the country calling code. JACS is going to, we have been thinking a lot about how are we going to introduce JACS, and our main challenge was with the adoption for enterprises. And our go-to-market strategy in this area is to propose JACS as a network saver, as a fail-safe mechanism. So for those entities with mission-critical systems who are looking to maintain their data availability at 100%, they can use dual stack nodes running TCP/IP and governing their TCP/IP-based traffic while having JACS as a standby. If there is an issue or a denial of service attack on the IP-based traffic, they can switch their traffic immediately over to JACS and work offline on fixing their TCP/IP-based network problem. As soon as this is done, they can choose to go back to their normal mode of operation. As I had referred, that our demo is an open source and is available over GitHub. And it is a simple demonstration of a client-server based setup where we can prove that we fully transport data over CLNP rather than using TCP/IP. Moustafa will take us through one of the most important features of JACS, which is the mechanism of address allocation.
Yeah, okay. So we talked about the IPv4 and IPv6 and how IANA and the 5 different RIRs are the entities who are taking care of the address allocation and address, creation and allocation for the different service providers. In JACS, there will be no central authority as we've identified. It will be over blockchain. So for each JACS site, there will be one node that will be acting as the requesting node, and it is the blue one here, requesting addresses over JACS platform. And then it receives a huge block of JACS addresses that it can delegate further inside its own domain to all nodes. But instead of having the node to deal with each and every single host or server or laptop or desktop or printer or any kind of networking device, there will be delegates. Those are nodes taking care or delegated to reassign and reallocate the requested addresses to other domains. So in the case of the brown delegate, it will take a chunk of the allocated JACS addresses and will be able to assign part of this chunk to its own internal domain nodes. The same goes for the green delegate and so on. So by this mechanism, we are starting from the address request, address allocation, and then the address assignment. Next, please, Mohamed. As we mentioned about Ethereum, it is very costly to store 1 byte of memory over Ethereum. And we've highlighted that we've worked around that by only storing the hash on-chain and storing the addresses off-chain or over IPFS. But what about the actual gas? So JACS will be created as a dAPP over Ethereum. So for any requesting node, like the blue one that we talked about in the last slide, if it needs to request some addresses from the JACS dAPP over Ethereum, it needs indeed to send some Ether. So in order to overcome that, we are going to pay the Ether gas on behalf of our users by introducing what we call a publisher node. So the requesting nodes need only to hold the small and minimal amount in JACS token and send that amount of tokens along with a digital signature. It's like a check to the publisher, and the publisher will take those and send them all along the Ethereum blockchain, along with the required fee to be paid for the Ethereum block miners. As we said, miners need to be incentivized with a small fee in order to be able to mine and produce blocks over the Ethereum blockchain. So in summary, we are gonna pay the Ether gas on behalf of our users. This slide shows the storage of the hash on-chain and the actual database of addresses off-chain with the IPFS. So it's only a demonstration with Ethereum and IPFS. That will be the case during JACS operation over Ethereum. And this one shows the case when JACS will work on its over native blockchain, starting from official release version 2. There will be no need for any IPFS because actually it's going to be JACS native chain. So all our the storage will be JACS. It will belong to JACS. No need to pay anyone. No need to pay anything. We are going to take care of the block producers or miners. So no need for any IPFS. Addresses are going to be stored on chain. Yeah, Mohamed talked about a couple of mechanisms. So on how to connect the different JACS over the internet. As we all know, it's very obvious that the internet, as we speak, is purely based on IP, TCP/IP, IPv4, and IPv6. So how would we be able to connect different JACS sites over the IP internet? We cannot start by saying, you know what? To the internet community, we've created a new communication stack. Let's get rid of the TCP/IP and move to that stack. No, definitely it will not make any sense. So we need to find a mechanisms on how to transport data between different JACS-enabled sites over the internet. The first mechanism is to incentivize our early adopters to be enablers for the JACS operation. How? By giving them token, by incentivizing them with JACS tokens. Thus, they will be more than welcome to sacrifice some of their computational resources and bandwidth resources to connect or to tunnel between two different dispersed JACS sites across the internet. So they will be acting as the intermediary between those sites. And that is only as the first mechanism. The second mechanism will start when we have the official release version 1, where we will have JACS public cloud. Public cloud, yes, it will be like Amazon AWS, it will be like Microsoft Azure, it will be like DigitalOcean. It's a public cloud, but it's gonna be purely based on JACS. So we don't need at that time any enablers or any early adopters. We are gonna incentivize the community anyway, but we are not gonna ask people to help us tunnel traffic between dispersed JACS sites because we are gonna do that over JACS or via JACS public cloud itself. And it's gonna be the second and like long-term mechanism till we reach the end goal of transforming all TCP/IP to JACS.
And let me talk maybe about the official release version 3, which we aim to be produced as a bundled product over hardware. And the hardware of choice here is white boxes. And white boxes are Linux-based networking equipment that are running a small network operating system that allows out-of-the-box network installs and programs to be running over the bare metal of the white box switch so as to perform the routing and switching activities. The white box is a Linux-based machine, as I said, and it is running a network operating system on which we will be installing JACS so as to perform the data traffic transport activities based on the JACS traffic. This is not only a technological choice, but it is also a commercial choice, because we are looking at a market opportunity that is growing at a cumulative annual growth rate of around 22% and is aimed to reach around $25 billion by the year 2025. So we want to partner with a technology that is growing and gaining market share rapidly, so as to enable us to market or distribute JACS and have more adopters to JACS as networks are modernized from legacy equipment onto white boxes and open source network based equipment. Speaking also about the business aspect and the economics, Moustafa will discuss and explain a little bit on how we are working on the token economics.
Yes, and the term tokenomics came actually from combining token and economics. So it's tokenomics in short. So tokenomics is the economy of tokens, because we said that JACS is a blockchain-based solution, starting over Ethereum and then later on over its own native blockchain. So there must be a token to unlock all kinds of services over this platform. And we need to define a certain amount of tokens. So how many tokens are we gonna create? It's 1 token, 2 token, billion token, 10 billion token, or what? So because we are dealing with binary and all about addresses, and based on many complex calculations, we've reached the right formula of assigning or of creating only 2 to the power of 29, that is giving us the 5,036,000,000 and change tokens, and that will be a finite supply of tokens. So we are not gonna have any extra token created after that. And those tokens were actually created a few months ago. So JACS tokens do exist as we speak. Again, we are gonna depend on smart contracts. We depended on a smart contract for the token generation, and we are going to depend on a smart contract over Ethereum for the public crowdfunding that is gonna happen in a few months from now. The different categories of token, we can see that we have the a huge amount, 50% of token are gonna be available for the crowdfund, some for the pre-crowdfund activities, some for the team themselves. We need to incentivize ourselves and our teams and our advisors, of course. Some is gonna be for the company in order to come up or develop any future. Maybe we need to acquire some company later on, so we need to hold some tokens in reserve or in like some kind of safe to be able to be used later on. And we need to incentivize the current IPv4 owner to encourage them to move away from TCP/IP and try JACS, and as well as bounty and airdrop. Airdrop is a mechanism, it's a well-known mechanism over blockchain, where all of a sudden one day we decide that we are gonna distribute tokens for free, as if tokens are being airdropped to the blockchain users or Ethereum blockchain users in specific. Based on the amount of crowdfund that we are gonna raise, and that will be an accumulated one based on the angel investment and private crowdfund and public crowdfund, that will determine what kind of or what mode of operation we are gonna take. Is it a slow track or is it a normal track that will be in accordance to our timeline? Or maybe if we raise a huge amount of money, we can go for a moonshot where we can squeeze all the development timeline and move quickly and producing the version after the other till we reach the end goal. And maybe if we raise a huge amount of money, that we are gonna make a mass shot and it will be more and more squeezed than the original timeline. The token is itself, it's called JACS. Its ticker is called JACS. It's 18 decimals, so you can divide it, or you can have 18 place for fractions for a single token. You can divide it to the 18th decimal location. It's based over Ethereum, so it follows the well-known standard over Ethereum named ERC20. Once we have JACS blockchain starting from official release version 2, we are going to have JACS token over its native chain. So how we are going to convert JACS tokens over Ethereum to JACS tokens over native blockchain, it's going to be one-to-one. So if someone holds 100 JACS tokens over Ethereum, they are going to have 100 JACS native blockchain once JACS blockchain is created and up and running. As we said, it's a pure utility, meaning it's used as a key to unlock all kinds of services over the dAPP. And as we said, any individual service provider, company, it doesn't matter. It's all becoming anonymous to us because it's all based on blockchain, you know? So anyone can request JACS. They need to pay a small amount in JACS token. There will be no maintenance or renewal fee after that. Quickly, the JACS rules. The most apparent one is abundance. We have theoretically infinity number of addresses. So we are always marketing with that term that we have a global unique address for each grain of sand on this planet and even beyond. All addresses are unique. There will be no need for any kind of NAT, network address translation. There will not be any private JACS addresses and public JACS addresses. We don't need that. We have abundance of addresses, and we can assign a public unique address per node or per machine. Aggregation, we are going to take care of the internet. As the networking guys may know, the internet routing table as we speak is exploding. Every now and then the size of the internet table increase because of the addition of IP subnets, IPv4 subnets. IPv6 came into play 15 years ago, as we discussed. So the internet routing table is holding huge amount of routes. But we are going to take care of the aggregation. And because of the NSAP address format, we can always, let me say, aggregate or summarize those addresses into few entries so that we can keep the size of the internet routing table in moderate. Anonymous. It's blockchain, no one knows anyone. It could be good for us, for the users, could be bad for government, let's say, because they are not gonna verify who is doing what. But again, it's the new internet era. We are talking about Web 3.0, where all applications will be distributed and decentralized. Being anonymous is not, or it's not gonna be a luxury anymore. People need to browse the internet in a secure way, in a very good way, as long as it's secure and legal actions are only performed, or legitimate actions, I would say, should always be performed in a good manner. Fairness, it's all about fairness. Anyone acquiring addresses, they will have lots of addresses to deal with. We are not gonna allow people to pay more because they are a service provider, or for a mobile operator to pay more than an individual. No, everyone is paying the same small and minimal fee, and that's it.
In conclusion, I would like to summarize what JACS is mainly about. JACS is a very ambitious project. We are looking towards global reach. We would like to provide a fully decentralized infrastructure for the Internet 3.0 applications to plug in on top of our framework. We have a clear go-to-market strategy where we are tackling the different target customers according to their needs. We are providing a fail-safe mechanism we are using our initial adopters as enablers and incentivizing them, making sure that they are happy to share their resources. We are making sure that we are putting everything on a public cloud to accommodate for the growing traffic profile. And at the end, it is a bundled solution. It's a fully end-to-end solution that could be used as a network modernization alternative as the networking equipment is going towards the open networking standard. It's a consensus-driven blockchain, so the community has the final call on how the JACS is going to be developed, and it is an open source project. However, of course, there will be a commercial version as well, so as to be able to provide professional services and technical support. Our target customers are basically everybody. We are looking to reach the whole internet. So individuals, enterprises, and service providers, and for each there is a solution that JACS provides. I would like to thank you very much for being with us today and listening to us for a bit more than an hour now. And as a small token of appreciation, I would like to offer you some of our address blocks and tokens. If you would like, you can fill in our form, and you just mention the date of today in the field named how much do you intend to invest in JACS. Just put the date of today, and we will be happily sending you a JACS token reward equivalent to £100 if you would like to do this in the coming couple of weeks. And now we can go to the questions if we have some in the chat, and if anyone would like to go ahead and post questions. I think we can unmute everyone, Mustafa, now, if you don't mind.
Yes, of course.
And do we have questions on the chat window? If you can read them.
No, we don't have any question on the chat window. So, but again, anyone can feel free to ask. You're welcome. Thanks a lot for the useful info. You're welcome.
I was going to ask about the Internet of Things.
Yeah.
Well, I mean, the thing about the Internet of Things, you get a huge tidal wave of new kinds of data. Will your solution help facilitate the Internet of Things?
Exactly, because of the basic nature of Internet of Things. It needs lots of addresses, you know. So think about a car, you know. Think about a Tesla. So you can have each and every sensor in Tesla or a modern car having a real address. You cannot do that with IPv4, you know. So I know that there are other mechanisms on how to keep the sensors talking in private communication channels, and then getting the car to do NATs or some kind of NAT at the end. But again, think about it this way. You can have each and every sensor having a global JACS address and browsing the internet as usual. So you can have your
another take maybe at the benefit to the IoT applications that JACS providing real unique address to each and every sensor is that the nature of the IoT applications as they stand today are based on, I would call them closed systems. So if we go to the Tesla reference, The sensors are indeed able to connect over the internet, but at the end of the day, they are able to send information to the Tesla servers only. Maybe to report diagnostics, to report faults, even to book services, and to the extent that the Tesla environment can check if the spare parts are available or not available, and can assign a service slot for this specific car. However, there is no inter-domain communication possible. And you might ask me, and I might not be able to answer, why would the oil sensor in a Tesla car want to communicate with something that is not related to the Tesla system? And at the moment, I do not know. But I am sure that this is going to open a lot of opportunities in the future. And this is what we are looking to do.
Yep, and we have other questions as well. Thank you for the presentation. You're welcome. Are there any competing frameworks on the market? In that nature or in that sense, no, as far as we know. There used to be other solution attempts. Some of them are still running as the NAT. Some of them are brilliant as the IP chain. And we have Jordi with us now. But again, they are solving part of the issue, but some aspect of the issues, but not all the problems that we've mentioned. So no, there is no true competitor as we speak. Looks like JACS scope is huge. Are you cooperating with any non-for-profit organizations? Mohamed, this one maybe is for you.
We have applied to a few incubators. And this is where we are taking our time a little bit at the moment. And just to refer to the roadmap, we are post MVP or prototype phase. To be able, of course, to reach our ambition, it is a huge project, and we will not be able to fund it ourselves. And for that, we will definitely need to cooperate with huge organizations, not necessarily non-profit ones, but typically organizations that are based for non-profit, provide incubation, provide services. And we are in contact with a few in the UK, and we are starting actually by the end of this month a 3-month program to manage to move further in our development.
Awesome. Question: why would a typical family of 4 with kids wants to use JACS? That's a very nice question. Because of the security, you know. So I'm not sure if you are like me or any of your kids is like me, but I don't want anywhere in the world, even in my home country, or even if I'm traveling, to be censored, that the information will be censored. I don't want to be in somewhere where I cannot use my Facebook, or I need to have a VPN in order to access Skype or access some kind of contents. JACS indirectly will overcome all these issues. You don't need to have a VPN because it's going to be very secure. It's going to be very open and very transparent. And remember, it's all based on blockchain. So because there will be no central authority, no one would ever be able to deny someone from doing something. I know that that may help other illegal activities, but again, it's all about the community who is driving the blockchain. As Mohamed mentioned, it's a community-driven blockchain. You know, so if there appear to be some kind of illegal activities, the community will agree on changing the consensus of blockchain and take the necessary action. Remember, we are creating JACS, but we are not controlling JACS. It's like we are creating a highway, but once You create the highway, and once you develop the highway, you cannot control which car should be using the highway and which car shouldn't, you know? So that's my answer. Thanks for the presentation, very much. Thank you so much. Obviously, we are seeing issues with the IPv6 adoption at the moment, and this doesn't really show any immediate signs of improving. How does JACS plan on overcoming this same adoption challenge? Exactly, that's a very good question. Thank you so much for asking. That's why we are incentivizing people to do. With the IPv6, no one was offering any kind of incentive to the community or to the service provider to change to IPv6, unless they are having a real issue and a real need. So we are talking about big, huge telco operator like AT&T, like Verizon, like Deutsche Telekom, you know. So those need to move to IPv6 and transform some of their clients to IPv6 because of their need. But for other operators, it's nothing, you know. So why would I bother and buy high-cost equipment that would support IPv4 and IPv6, or why would I need to do and train my people to do with some kind of carrier-grade net in order to move to IPv6 while I'm very happy? So there,